Okay, so Discover is basically a Python application. The backend is written completely in Python. So if you did want to get into how it works, you can actually get right into the source code. So it's completely open source, hosted on GitHub. The main behavior is here in the server.py. This is actually a server that gets launched and works in the background, and it's able to communicate with your Grasshopper model. So all the optimization stuff is taken external Grasshopper, and it's handled by this Discover server. Okay, so that's that code. And then if you want to dig into more of the backend kind of functionality behind the genetic algorithm, in this SRC folder, these are the two collections of Python code which handle all the optimization. So in objects, you'll see like a design class. This is for each design. You have things like design number, ID, parents, objectives, right? Like it's storing everything about each design. And then you also have this job class, which is like the optimization job itself. It has things like the design queue, a log of designs, parents, other things. So it's handling all the things about how to do the job. So it has a function like to create the next generation of designs where it's looking at elites, it's creating children. So I tried to keep this code, not expecting you to be able to work with it or anything like that, but eventually if you find these things useful and you're doing more and more, gaining more and more knowledge in Python, you can actually dig directly into the code and start to change some of those functionalities. So we said, earlier, that's the way it happens in the code because I made that decision. You can actually change it directly in the tool as well down the line. And I've really tried to keep this as basic and kind of readable as possible. On the front end, it's just written completely in JavaScript. So that server is running in the background, and you're going to, as the user interface, you're going to be working in the browser. So there's going to be like a browser kind of interface so you can control that server. And that whole browser interface is built in JavaScript. There's a HTML file in the templates folder, which is the whole kind of front-end interface that we'll see in a second. And then all the dynamic content things are in a few JavaScript files. So there's the UI component, which allows you to schedule jobs. This becomes a lot worse code because I'm a lot worse at JavaScript than at Python. So if you're a JavaScript person and you want to contribute to this project, or you know someone that does, please. And this is the whole Explorer interface to do the scatter plots and things like that. Okay, so that's basically it. That's the whole code base. And this is what we're going to be using. Now, you don't need to know Python or anything to use it, but because it's like a Python app and not a full-featured software, the installation is a little bit more complicated than you would typically have. So we're not going to like download an exe and install it. We actually have to run it as a Python app. And so there's two options for this. The easiest one is to use what's called Docker. Has anyone used Docker or heard of Docker before? So Docker is just a platform for distributing apps written in Python. So instead of going through and developing like a whole software solution that can run on different platforms, Docker allows you to deploy Python code across different machines. It basically handles all the dependencies. The problem with using Python code is you need to have all the dependencies. Like each machine you install on has to have the right libraries, the right version of Python, etc. The Docker makes that easy by actually using what's called virtualization. It'll create a virtual operating system on your machine and automatically get all the dependencies and run your code. So basically, you just have to install one thing, and that's Docker, and then everything else is automated. That's approach one. That's what I recommend. And I've actually rewritten Discover to be deployable in Docker. It's one of the main improvements of this version. But there are cases where Docker won't work for you. Like for example, on my old MacBook, Docker doesn't work in the boot camp. So in those cases, there is a solution. You just have to run it natively in Python. And all that means is you have to install Python, you have to install the dependencies. Okay? So I'll show you a kind of overview of how to do both, and then I'll create some text documentation over the next couple of weeks covering those things as well. Okay? And so these installation things are important because it depends on where you want to run this. Okay, this thing is not installed on your school computers today. So if you want to do this on your school laptop, we have to work with IT to get it installed. And the way they do this is just through individual ticketing. So you'll submit a ticket, and then we can have both versions of how to install it and see which ones work on your computers. Hopefully they can just install Docker and then everything else you can do yourself. But if Docker doesn't work on those machines, then we have to install Python things. Just so I know, who of you is planning to use your own laptop to do most of the work in this class? Okay. Anybody? Let's do the other one. Anybody don't have access to a personal laptop to do work that has like Grasshopper installed on it? Don't have access to your own laptop? So that means if we can't get it on the school laptops, as a backup, everyone's got a laptop they can use. Is that right? Okay. That's good. I mean, if that's not the case, you can also email me, just so I know. I just want to know a heads up if anyone's going to have major issues because, yeah, the IT thing in the school, you know, any school, it's always complicated when you're doing this kind of like software that's just released the day before class. Okay, so if you're using your own laptop, you of course need Windows. It doesn't support Mac Grasshopper, unfortunately. You definitely need Windows. And otherwise, we should be able to figure it out using one of those two options. If you want to get installed on your studio computer, uh, let me know. We'll need to work with IT to do that. Okay? Any questions about that? Okay. I think the best way, if you have your own laptop, it's probably easiest to do that because it's so much easier to troubleshoot when you have the permissions. Okay. So very quickly, I'm not going to do like a full demo here because like you guys aren't following along. But just to have it on the video, I'll go through the steps. So to do the first method of installation, you just have to install Docker first. When you go to Docker, you just go to Get Started, go down to Developer here, Docker for Developers, and go to Download for Windows. Now, if you don't have an account with Docker, it's going to ask you to make an account first. You have to make an account. I have one here. I'm already registered with Docker. It's a free account. You have to register, and then you'll get this download link. And you just click this, and you'll download an executable. And you just run it to install it just like any other program. There's one detail, I believe, about Docker I wanted to mention. Must register an account. Oh, if it pops up a window saying, do you want to keep the default Linux containers or use Windows containers, just keep everything default. Just do the default Linux containers. So once you install Docker, it's going to be this program which just every time you launch Windows, it launches automatically. So you can see I have it running down here. My Docker desktop. It says it's running. If you right click, you'll get these options. But other than this, you don't really have to interact with Docker. It just has to be running in your computer for you to use it. Right? So it's kind of this like tool that runs in the background. Okay, so I'm going to cancel that. So once we have Docker installed, we go to the next stage is to download Discover. And to download it, you just have to just download all these files from the GitHub repository. So this is linked from our syllabus. This repository on GitHub has all the code for the program. So this is like the program's website, you could say. All right. So to download this code, if you're familiar with GitHub, you can clone it. You know, you can work with it through GitHub. If you don't use GitHub, you can also just directly download the zip file of all the files. That's probably what I recommend if you aren't already using GitHub. By the way, GitHub is like a kind of Google Docs for coders. And there's different ways to kind of work with these repositories. You can also just download it directly here. So I'm going to download the zip file. Okay, it should be pretty fast. Let me give you the zip file. and just go ahead and unzip it. And it's just going to give you a folder with all of these files. It's exactly the same thing we see here. Right? This is all the code. Okay, and once we have Docker running and we have all this code downloaded, all you have to do is double click on this file called run.bat. This is basically a script that will go through the whole process of installing the program on Docker and launching it. All right, so if you run this, it's going to first try to install all of the dependencies it needs, and then it's going to launch this web browser where we should see the user interface, and the window should stay open and run. Now, right now, just this morning, I'm having some issues running it on this computer, even though I was working on my work one last night. So I'll have to troubleshoot that. But it's a good way to show you the other way of using it if you can't get Docker to work. So right now, I'm having some issue with my Docker. It's not working. So the other way to make this work without Docker is to just run it directly in Python. All right? And oops. And to do that, I recommend downloading a distribution of Python that comes with this Anaconda package. Now, we've been using Python in Grasshopper, right? And that's a version of Python that lives within Grasshopper. To use Python in our system on Windows, it doesn't come with Windows by default. You need to actually install it. So you can install just Python, but a much easier way to do it is to just install this software called Anaconda. And it includes a Python version and a bunch of other libraries that are commonly used. So if you can't get Docker, right, you need to get Python. The best way is to install this Anaconda. You just go to download and make sure to get the right one for your system. You want to go to Windows. And here, the main thing that's important is that you get the Python 3.7 version. Discover runs in Python 3, not Python 2. Okay, so download this. And then you go through the process of installing it. Now here, it's pretty straightforward. You keep all the defaults. The only thing that you have to watch out for, and I'll include this in the documentation, is there's a window that pops up asking if you want to add Python to your path variable in your environment. Okay, you'll see this later in the instructions. I don't expect you to remember it. Just make sure it's clicked to yes. You want to install the path variable. Okay, so once we have Anaconda installed, you go to your start menu and just search Anaconda, and you get this Anaconda prompt. Okay. This is the command prompt, and this is going to let you work with your Python. And all you have to do once you so the last thing you need to do to make this work is to make sure you have all the libraries that the Discover tool depends on. So this is something that Docker handles for us pretty well, but we have to do it manually if we're running it straight from Python. And to get those libraries, you just go to your Anaconda prompt and you type in, let's see, pip install, and then just list all the dependencies. There's only 3. And eventlet. Okay, so these are the 3 Python libraries that I use to Discover, and we just install them using a set of commands. Hit enter. Okay, it's going to download anything you don't already have and install it. Now we should be ready to go. Just as an overview, right? We have this Python app. We need to run on our computer. There's 2 ways. One is to install Docker. And once we have Docker running, just run this script and it'll automate everything. It'll create a virtual Linux operating system on your computer. It'll download the right version of Python. It'll download all the dependencies and it'll run your code. It'll even launch the web browser for you. It's completely automated, by far the fastest way to get into this. If that doesn't work, then we have to download Python manually through Anaconda. And then once it's downloaded and installed, we have to run this command to install the libraries that Discover depends on. Okay. Once we do that, we can then run the server from Python. So we want to, in our command panel, do cd space, that's to get into a folder, copy and paste the name of the folder that you unzipped. Now we're in that folder. Now we do Python. We tell it to run our program in Python, and then we just link it directly to server.py. Okay. This will actually run our server in Python using our just downloaded version of Python. Okay. You should see something like this. This is basically our server started. It says it started up on this path. This is our local path. So the last thing we need to do is, now that this server is running, and this window should stay open, like you shouldn't get any errors here or anything like that. It should just kind of stay open on this stage. This means that the server is running and it's ready to go, right? And it's listening for things, like our input, and also talking to Grasshopper. Last thing we need to do is just open a web browser and go to this address. This is your local path. So I'm just going to open Chrome. And here I can go to localhost 5000, or use that address there, 0.0.0.0. Same thing. It's just our local path to our computer on our local network. All right, you can see the server is already active. Okay, so there we go. This is the interface of Discover when we first launch it. It's running in the browser and it's talking to the server. So while you're using this window should always be open. If you run it through Docker, you're going to get this window also. It pops up and it kind of tells you what's going on in the server. And this is a good way to debug as well. Like when things go wrong, I'll ask you saying like all the commands and everything that are being called as the two talk to each other. Okay. So this is the interface we'll be using. Let me just go over the different elements here. On the left side, we have our problem definition. This is where we tell Discover how we want it to run the optimization job. Okay. On top, we have inputs. And then we have outputs. And we have options. Right? So we'll go over those in a second. Down here, we have a set of buttons to run the optimization. So this one will take the input definition and actually push those inputs to Grasshopper so we can see them in the model. This will start the optimization job based on these specifications. And then this one will stop it. This whole area here is the visualization window. It's that this Explorer interface of the scatter plot. And here we can select the different parameters to put on the scatter plot, and then here we can record different designs. Okay, so you've seen some of the screenshots in the slides, and we'll do an example pretty soon. So these controls just control which optimization job is visualized, and then here you have control over the visualization parameters. And down here you have a log screen that just tells you like what's going on in the process. The job is started and where it's at. Okay, so that's the interface. If you got this far, you're doing great. The server's running, and we're seeing this interface. The last thing we need to do is launch Rhino, Grasshopper, and connect it to the server. So with the library, I have just 4 special nodes that I wrote to actually communicate with the server from Grasshopper. All right, so what I'll do next is I'll launch Rhino. And I don't need to open any file here. I'm just gonna go ahead and directly launch Grasshopper once this comes up. Oops. All right, so I have my Rhino. I'm going to launch Grasshopper. Okay. And the first thing I need to do is bring the Discover components into my Grasshopper. There's just 4 components, and they're actually included in that package that you downloaded from GitHub. So in that package, there's a Grasshopper folder that has samples. These are sample projects that we'll look at in class. And then it has user objects. And these are the 4 components that we're going to use. And all you have to do is open a version of Grasshopper, select these components, and just drag them into your Grasshopper. All right? And what that's going to do is it's going to create a new toolbar called Discover. And these are the 4 components we're going to use. Okay? All right, so there's 4 components. They do different things. We just go over it quickly. There's the connect component, which connects our Grasshopper model to the Discover server. There's a screenshot component, which takes a screenshot of our model and sends it back to the server so we can visualize each design. And there's a get inputs component, which gets inputs from the server and uses them to create our Grasshopper model. And there's the send outputs component, which takes the outputs of our model and sends it back to the Discover server. So when this thing is running through these components, these things are always communicated, right? So remember, it's a kind of iterative process, right, of optimization. So the server will define, after you enter all the parameters here, the server will define the first generation. It's going to schedule it, and it's going to test each one through Grasshopper. Basically, one at a time, it's going to send a set of inputs to Grasshopper. The Grasshopper model is going to compute. It's going to generate the outputs, and it's going to send those outputs back to the server and get the next input. So there's going to be this kind of automated loop happening between the Discover server and our Grasshopper file. Both have to be open at the same time. They're talking to each other, right? And that's why it's important, like unlike other Grasshopper plugins, I thought it'd make a lot more sense to keep this external from Grasshopper, because this thing is like a kind of gorilla sitting on top of Grasshopper telling it what to do, right? So the Grasshopper model becomes kind of like a slave. It's just computing designs for Discover, right? So our server's running. Right here we see Discover started. There's a connection to the server. So now we're in Grasshopper. We have these components. First, I'm going to drag in the connect component. That's going to establish a connection to the server. It's basically going to tell Discover which file in Grasshopper you're working with. And this is because you might have different Grasshopper files open. Whichever one you connect last is the one that Discover is going to send stuff to. All right. Each of these components have a little status output, which is really useful. Right? Each one of the 4 has a status output, so you should always connect a little text box to see what's going on. So when I first drag it out, it says, please save your Grasshopper file before connecting to the Discover server. This is because when you first make a file, it doesn't exist in your computer, so Discover can't talk to it. So before you work with Discover, you have to save your file. I'm going to save the Grasshopper document to my desktop. Test. Okay. And now this connection works basically by just toggling this connect input. The easiest way to do that is just to connect a button. Connect a button to this. Each time that's toggled, it's going to basically run some code that checks whether the Discover server is running. If it's running, it'll connect to it, and it'll give you this status, server connected. If the server's not running, it's going to tell you there's no server running. Okay. So that's our basic connect. Every time we click this button, it's going to reconnect to the server, and you see the results here. Right? You should see in your web browser, connect to the Grasshopper file. It's going to have the actual name of the file. Right? So you can double check this as well. And that's why it's important to save your file. It's going to be whatever my file name of my Grasshopper file is. Now, it doesn't matter where this Grasshopper is saved to your computer, right? But that's why the connection is key, because they don't know where each other are. They have to do this active connection before before they know about each other. All right. Now, once we're connected, out of the connections output, we're going to get two files. This is the way that Discover communicates with Grasshopper, by actually writing out messages to these local files. You see if they're automatically stored where you install Discover in temporary directory. This is the unique identifier of that connection. So every time you connect to Grasshopper, it creates a string. That's how we can make sure that it only controls the file we want to control. And then there's two pathways. One pathway is going to trigger the inputs component, and the other connection is going to trigger the screenshot. We have to have these two components to make sure that the screenshot is taken only after everything's finished. All right. So what we need to do is basically take these two connections and break them out. So we're just going to use a Grasshopper component called explode tree. You can type in bang, and I'll give you a link to it. This is a really useful component just to take like a list of things and break them out into individual outputs. So we just connect that here. So right now, both of those are still on the same branch. We can just right click and go to draft. And if we want to simplify, and it's going to give us those two pathways, those two files as separate outputs. This is just a built-in Grasshopper component. And now we want to take those and connect them to one to our inputs component and one to our screenshot component. So let's do the inputs first. I'm going to go down here, get inputs. Very similar component. The only input is a connection, and I connect that to not directly my file, but I have to have something in between to read that file. So I'm going to use the read file component. And then the results I'm going to plug into the connection. So it might seem a little bit weird at first, but what's really happening is Discover will write a message to that file in your temporary folder. And then when we connect it to the read file, Grasshopper will basically read that file anytime there's a change to it. That's the kind of backdoor hack I did to make these things communicate to each other. Okay. This read file component will update the Grasshopper definition anytime there's changes in the file. And if you look at what's coming out of this, do you see that? It's just the date and the time. It's a kind of ping. So the Discover will take that file, local file, and rewrite it with just the local time. And just because that file is changing, it's going to cause this whole thing to execute in Grasshopper. Okay. So this is like just a trigger. All the actual mechanics of how it gets inputs is handled through the code in this component. The only reason we're using this is to just force Grasshopper to update. Right? That's the only way we can kind of get it to control it. Okay. And so now we're connected. We're connecting this file through the get file component into our connection. So now this is going to get triggered every time that file is updated by Discover. And out of here, we should be getting our inputs into our model. This is the inputs that we're going to use to basically control each design. All right. And then here we have the status. So we're going to connect received inputs from server, so everything should be going well. We haven't scheduled any inputs yet, so we don't have anything yet. So let's now go back to Discover and create one set of inputs that can be loaded into our model. So here you see this interface for specifying the inputs and outputs. We can have any number of inputs, any number of outputs, and they're constrained by these types. So this is like, I know this is already seeming very complicated, but you guys are actually lucky that we have this interface now. Before you actually have to type out like a Python dictionary with all your parameters and everything. Now you have this interface. So you can name the input. This is the text box. You can name it whatever you want. Let's call it my input. There's a X box here. You can click it to delete that input, generate a new one. You pretty quickly generate a bunch of inputs. They're automatically named in a continuous way, so you can get started really quickly if you don't want to kind of mess around with it. So under each input, we have this drop down, which specifies the type of input. Remember, as long as we're using this, there's only 3 types. pretty simple. And depending on which one you choose, there's some sub options that you can select. Okay, so let's go over it very quickly. With the continuous and categorical inputs, you can actually create sets of inputs very quickly. This is also very important, that if you have 100 continuous input parameters, let's say you just want 100 inputs between 0 and 1, in Grasshopper, you have to create like 100 different sliders, connect 100 different sliders to Galapagos. It's a huge pain. Instead, you can actually say, the length here, I want 100 different inputs. The default is 1. If you just want one control, just keep that as 1, but you can also make multiple. It's just a kind of parameter set, but each of those parameters in the set has to share the same min and max. So this is the range of that continuous input. All right, so you say, I want to create one continuous input, and I want it to range between 0 and 1. So I'm going to create random continuous variables between 0 and 1. The second type is categorical. So this is what we called discrete earlier in the lecture. Again, you have a length because you can create a set of any number of categorical parameters. And here you don't have a min and max, you just have the number of options. Because remember, this is meant to represent categories. You don't say what the min and max category is, you just say how many things are there. And if you say there's 4 things, it's going to create an integer. It starts at 0 and goes up to 1 less, right? So it's going to create an integer that's either 0, 1, 2, or 3 for 4 things. And you say it's 10, it's going to be 0 for 9. That's always how it works, right, on the input side. But then you can reinterpret it in Grasshopper however you want. Right? So if you have 4 options, you have to, in Grasshopper, specify how those different options are handled based on that 0 through whatever integer. Okay, and the last type is the sequence, and here all we have is the number of options. This is just the number of things you want to shuffle. So if we have 10 cities in a traveling salesman problem, we have 10 options here. Okay, so let me get rid of these. And just to start, I'm going to create one single continuous parameter with length 1. And now I'm going to go to test. Generate test inputs. This should be coming in to our Grasshopper here. So if we go to inputs, just create another text box here. Okay, so the inputs are coming out. They've been fed into Grasshopper, but you see they're coming in this Python list. So the next thing we want to do in Grasshopper is to create another Python node. And this is a little bit of a hack. We just want the Python node to interpret each of these lists. And it's going to take the situation, we're going to have multiple Python lists and basically translate it to a tree, a data tree in Grasshopper that we can use. And all we have to do is just connect the inputs to X, double click in here, and delete all this, and type A equals X. So it's going to set A to X, but it's going to do that separately for each list. And you do, through that, create a different branch in our tree for each list of inputs. So click OK. So now we see the actual input coming out in Grasshopper. And this will scale basically where when we have more parameter sets, they'll come in as different branches. And I'll show you that in a second. All right, and then we're going to have another one of these. Well, let's just see what happens when we add parameters first. And then we'll use another one of these bang nodes to basically separate those inputs out. Okay, so this is connected, right? So let me just dock this over here. And we can run this test multiple times. And we should see the input parameter changing. Right, each time we hit it, it's going to create another set of parameters. In this case, just one continuous parameter between 0 and 1. And it comes in here. So we can really start to use this to control our Grasshopper model. Cool? That's the basic essence, right? As soon as we can get this connection, we can run the genetic algorithm on the back end in the Discover server to do all the optimization. And it's also nice to separate out because this Grasshopper file can crash. We still have all of our data from the other designs. Okay, so let's say we add another input. It's going to be the same type. We'll hit test. Okay, so now you see what happens. There's 2 branches, right? Each branch is the parameter set. Now, if we say here for this first parameter, we actually want 10 different parameters to test. You see it comes in as a list of 10 parameters in the first branch. This is exactly what we want. Okay, so if you set up your file this way, you're gonna have that kind of expected behavior. And I'll give you the example files that are in that Grasshopper folder have all this already set up. So you don't need to do it from scratch. I'm just showing you one time sort of how to set this up. It's not so turnkey, right? You need these kind of intermediary Grasshopper functions. So let's check out some other parameters. Let's do a categorical parameter for our second one. We'll do 10, number of options 4. Oops. Test. Okay. There you see our categorical parameter, right? Generating random values, 0, 1, 2, or 3. Right, and this can be however many we want. We can do like 5, based on what you need. And let's do one more. Let's try our sequence parameter with 10 options. And actually, I'm going to change this one to 10 too, so we can really clearly see the difference between these different types of parameters. Okay? So hopefully that makes it very clear. 3 types of parameters. We're doing 10 each time. Here we have 10 random decimal numbers between 0 and 1. Here we have 10 random choices of 4 things, 0, 1, 2, 3, and 4. And here we have a random sorting of the numbers 0 to 9. Now we can consume this within our Grasshopper model. All right, and if we want to split these up to use them in our model, we can use another one of these bang nodes to explode the tree. What's cool about these nodes is, like, in this case, we don't need to graft or anything because we're already on different branches. But you see it's yellow. It says there's more branches than there are outputs. There's a really quick way. If you right click on the component and do match outputs, it's actually going to match to whatever you have. I find this a very quick way to work that, I can schedule some inputs here. I do test, and then I'll right click match outputs, and I should have the exact same number of branches that I have as input sets in Discover. Okay, and now I can basically treat these differently. I can have my floating point continuous parameters, and I can have my categorical parameters there. Okay, so let's build up a simple model to test this. I'm going to delete this input. And I'm actually going to make 3 different input parameters, all continuous, all one length between 0 and 1. Hit test, right click, match outputs. So now I should just have these 3 numbers. I'm going to use that to make a box. I'm going to first make a start point at 0, 0, 0. Just delete that actually. And I'm going to create a vector using these inputs. So my inputs from Discover are just going to control the position, the direction of this vector. I'm going to use that vector to move my original point. Let's see what's going on here. All right, so here's my original point. Here's the point moved according to this vector. And now I'm going to make a box, 2 points. Between those 2 points, it's going to give me that box. All right. And now, when I hit test, I should see different versions of this box. Right? So we can create different models based on changing these 3 parameters. I'll just have three numbers here, controlling X, Y, and Z. Okay. So we got the input side working, right? That's all we need to do. Here we have our basic box definition. Here we have our inputs from Discover, and here we have our connection to the server. Right? So we have these 3 pieces so far. So next thing we need to do is specify the outputs, right? How are we evaluating this design? We're just going to start really simple with a single objective. Keep the name by default. Actually, well, let's think about what we want to measure. Let's just start with just trying to optimize the size of the box. Right? I'm going to take the box. I'm going to calculate the volume. Right, and that volume is going to be my my metric. I'm going to set it up in Discover. So the type you can choose from 2, right? Objectives or constraints. Now with an objective, you just have a goal. It can either be minimized or maximized. That's it. Or you have a constraint, and the choice is a little bit different. You have a requirement, which is either less than, equals, or greater than, and then you have this number here. So that's how you construct your constraints. You say, okay, I have my constraint, maybe it's the volume, and the volume has to be, this is the condition for meeting the requirement. The volume has to be less than, let's say, 10, and then you're good to go. So any designs with a volume less than 10 pass, they're feasible. Anything over will be deemed unfeasible. We're going to look at constraints in a couple weeks. So it's going to be the last big topic. So until then, don't worry about it. Okay, because with optimization, you need at least one objective. You don't necessarily need constraints. It's just a way to kind of better specify the model. Okay, so we have objectives. We're going to make one objective to maximize. Okay, so it's set there, and it's going to be our volume. The next thing we need to do is actually create the infrastructure here to send those outputs back to Discover. So we're going to use our send outputs component. And I can just connect this output directly here, but because we have maybe possibly multiple outputs, I'll first make a merge node where I can keep plugging other outputs in later. I'm going to connect that merge, which would be like a list of things, list of outputs, to our send outputs component. I'll make another panel here to see the output. Now this component sends stuff back to Discover, so it'll tell you if there's not an optimization job running, it's going to tell you that. It doesn't have anything to do. Because for now, we're just testing different things, right? We're not running the job yet. So that component doesn't really have much to do. Okay, so the last thing I'm going to do right now is run the job. We'll see quickly how that data is generated, and then we're going to pick it up again next week. And you'll have this video also to reference to get started. Okay, so the last thing I want to do before I run the job, I have everything connected, but I need to create the component for capturing screenshots. Because as we generate this stuff, we don't just want to track the data about the design, we also want to see what it looks like. The last component here is capture screenshot. Drag it down here. This one is kind of parallel to get inputs. It works the same way. So we need another file component. We're going to drag the second connection here into the file component. We're going to drag that into connect. Right now, we haven't captured any screenshots, so it's going to say there's no such file. As soon as we run the job, it's going to be created. It's going to see it. And then that's it. Everything for capturing screenshots is internalized here. We just have this feedback, says no job running. Okay. Now everything should be set up. That's our entire sort of setup. We have our outputs here. This is our model. This is our outputs, screenshots, inputs, and connection. That's the whole kind of Discover setup. Okay, once that's set up, I'm going to go here, and then finally I need to specify the parameters of the job itself. This is the options. This is the hyperparameters, right? The meta heuristics here. We're going to say how many designs per generation, how many generations to explore after the first generation, the mutation rate. This is the percentage of designs that get mutated, 5%. Start. The number of leaks to carry over into the next generation, and whether you want to save a screenshot. The only reason to uncheck this is if you want to speed things up and you don't need to see the designs. Once that's set up, we hit start. And what we'll see is designs being generated. We also see a floating viewport come up here. This is going to be the viewport that's actually capturing the screenshots from. The first time it loads, it's going to try to scale it to the size of your model. You can also just kind of control yourself to make sure you get a good view. All right. So our job is finished. We only ran 4 designs, 4 generations. You saw all that happening. You saw the reports here, starting generation 1, starting generation 2, and then job finished. You also see another thing that when it started the job, it gave that job a unique ID, and it's populated that ID in this text box. So now we can hit load data and automatically load the data from that latest job. At the same time, it created a folder. Let's see where I installed it. For each job, it creates a folder with that name. So that name is going to be the name of your Grasshopper file and the date and the time to the millisecond, right? So this is always going to be a unique name. Each time you run a job, it creates a folder under your, wherever you download Discover data, and it's going to get this folder. In the images folder are all your screenshots for each design. And in the results file, you actually have all the data. You can always parse this with Excel or anything like that. It's actually the data that's being used to visualize it here. And then before we run out of time, just very quickly, this is the Explorer interface. So when you load in a job, you can look at the results. Now we have a single objective problem, right? So we have here all of the parameters we can visualize on the scatter plot. We have the design ID, the generation of the design, and here we have just one objective. If we have more than one objective, we're going to get other options here. So if we just look at this case here, what we're visualizing is on the x-axis the generation number of the design. You see here, this is 0, the first random generation. This is our 4 evolved generations. And on the y-axis, we're visualizing our single objective. This is the volume, right? And if we change this name, it's going to be the right name here. And we're maximizing it. So what we're looking here is actually the process of optimization over the 4 generations. Because it's a really easy problem, it converges very quickly. Right? So each of these stacks is kind of like a set of designs. There's 4 designs in each generation. So it starts low with small boxes, and then very quickly it converges onto a solution with a larger box. Now this isn't the largest possible box, right? Kind of converged too soon. So we can also try other things, like we can set it to run for 10 designs for 10 generations. We'll hit start. It'll populate our new design here, or our new job. We can load the data, and we can actually, as the design is running, keep reloading the data to see the most recent results. So right now we just have 1 generation. Here we have the emergence of our next generation, right? And we can see the screenshots here in the small boxes and the big ones. We can keep doing that. And there's a few buttons here you can explore. You can reset the zoom. This is totally interactive. So you can zoom in and out on the different axes all together. You can isolate the optimal designs. So they'll show you which designs are rank 1. Here we have 1 objective, so we have 1 best design so far. Right? And then now see in the 3rd generation, we got a little big, better design. You can also select designs, and they'll show up here. And if the job is running, it won't let you do this. But if there's no job running, you can actually click this, and it will reinstantiate the inputs from that design back into your Grasshopper. So as long as you have the same Grasshopper model loaded, you can always select designs here based on your filtering, see the designs here, and then click them to reinstate it. It won't work while this is running. So if I stop the job now, let's go back to Rhino. Here's a design. I can always select one of these, click the name here. It says reinstated design from this job. And here it is in our Grasshopper. Right? So as long as you keep your Grasshopper file consistent, you can always bring these things up. By the way, even if you reset the server or everything, as long as you have the name of that job, which you can get here, right? So I ran 2 jobs. I can just copy and paste that name and load the data, and I'll have it there.